over here, we can do it like a little if. So we can set the rotation angle, which is this. And then if hold to orbit is true, then we actually, rotation style, I suppose. We can make an enum. Rotation angles, we would then modify by time.delta time so that it equalizes for frame rate. And then over here, I guess I can get rid of this comment and put if hold to orbit is equal to false, then we set this. So now I can tune it. So by default, right now, I have to move the mouse constantly to move things, right? But if I go into my camera and I click hold to orbit, now if I move the mouse and I'm not letting go, but I'm not moving the mouse anymore, it'll keep going. And it's properly set to time. We probably want to increase the sensitivity now. Let's say we make it twice as sensitive by setting it to 5, which again is sort of like an inverse. So you can do this. It looks really cool, but I find it a lot more awkward to work with. But hey, you've got an option in here. You can mess with it. So I'm back to the more precise sort of this, where I can go a little bit this way. That's exactly where I want to be, which I prefer. Okay, what am I doing? Zoom. Zoom, zoom, zoom. Or dolly, 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 dolly. So we're going to move the camera backwards or forwards. And we want to make sure this is based on the camera's current forward direction, right? What is forward and backwards? Well, whatever angle the camera is currently in its local reference point, is moving backwards and forward along the z-axis. The z-axis is forward and backwards. And in fact, you can get that that angle quite easily if we say the camera dot transform dot forward. This is the forward direction of the camera. So what do we actually want to change our position by? Well, we actually want to change, I'll make this like, actual change of position is the camera's forward direction multiplied by delta. What's the right answer here? Add delta? Again, this, it's sort of Z related. Are we adding? Are we multiplying? How are we doing it? Well, here's the thing. Imagine the situation where you are 1 unit away in Unity space, right? You've got something here, your camera's here, and it's 1 unit away in Unity space. If you change the position of the camera by a full unit, say away, right? We're going from a 1 to a 2. We're doubling the distance from the object. So that's a change of 1, doubles our distance. But let's say we're in a situation where we're 100 units away, and then, again, we just add 1. Well, that's only a 1% difference. That's not noticeable. So you don't want to use the mouse ticks. Assuming you've got a clicky mouse like I do, right? You don't want every one of these ticks, or, every X degrees around the mouse wheel to be equal to 1 or some fixed unity amount. Instead, you want to do it a percentage based. You want to say, for every tick of the mouse, we're going to change the camera position by 5%. It doesn't matter if we're super close or super far. Every tick of the mouse will always change it by 5% or some sensitivity number. And that will actually that will look natural to the player by doing something like that. That will feel a lot more natural. So first of all, do I want to care about this? I don't know. So how would we do it? Well, our change of position would be like our forward vector. Say, if we were dividing it by 100, this would be 1% of our distance multiplied by some delta number. We don't know what delta will be. It actually depends on your computer things, like how much delta will be, which is the movement around the axis, is going to be some number. How much really depends on your computer settings, which is, again, why you got to be able to tune this. So really what we need is a public float zoom sensitivity. Actually, I won't make it a public start off with because it'll make it a little easier for me to pick up like a reasonable default. Let's set it like this. So that's the actual change position. And then what I want to do is for the camera dot position, dot transform dot, I could go position, or I could use the translate one, which I guess would be fine. We're going to translate it by the actual change of position. We're going to see. We may have to mess around with like local space versus world space. We'll see how it looks. So right now, so we're not, The actual change of position is going to be based on the camera. Do we move the rig? No, we don't move the rig. We're moving the camera. Yep. Okay, we're good. Okay. Let's see what this does. Might be completely wrong. Well, it's clearly too small. If you see the number over here, we start at -10, and as I scroll, it's like 9.96, 9.90. Okay. So that's a bit too small of a number. Or rather, like we have to, again, this is inverse sensitivity. So we're going to make it 10 times as powerful here. Let's see what this looks like. All right, well, I can actually see it move now, but that's still no good. So we'll use a 1 as is. It's actually, rather than a sensitivity, I should call it divisor. Okay, that feels a little better, but it's still way too slow. I'm gonna rename this to zoom multiplier, in fact, because clearly that's the direction we're actually gonna need to go into. And I'm gonna change this to like 5. So now we're actually, instead of dividing, we're multiplying. I mean, I could have gone to decimal points, but there we go. There we go. And we can see when we get close, the changes. So it's changing by ½ a unit per click here. Oh no! I'm dumb. This is not exactly what I want. This is the correct direction, but I forgot the transform.forward is always a unit vector. That's not what I'm looking for. Do I want to use the position as is? Because this is always a unit vector, so we're not doing the percentage thing the way I was talking about. Yeah, actually, you know what we can do? Because it's always relative. What I can say is just something like new position is equal to the old position. And we are just dividing it by some number. Yeah, see, this is why. Let me just try some hard coding here for a second. And we're just going to set the position. Oh, it should all be local position, though. Hold on. Local position. So this is the difference or the distance between us and the rig. And we're just updating that. Plus this, hold on. Let me actually change this to be the change, which is equal to 1/20th to start off with of our current position as a number multiplied by delta is the change we want to use. And then the local position, can I just do a plus equals? I'll have to rename these. Let's see if this is a little bit better. Okay. Again, the numbers are too small, but I think the math is going well. Let's just use this maybe as is. Well, no, we're going to want some sort of sensitivity number in here. Zoom multiplier 2. All right, there we go. And so when I'm close, a single tick of the mouse is changing by less than 1. You can see here, I'm going from 2.6 to 2.1, so less than a 1. But when I'm far away, a single click is going to bring me from here 13.2 to 15.9. So, okay, I'm doing it right now, finally. Thank goodness. Now, it does have the problem where it gets a wee too close or a wee too far. So we probably want to clamp that somewhere in there, which is really easy to do, right? So what we'll do is I'll apply the change over here. Yeah, that's fine. Or, yeah, okay, hold on. Let's say this is the, I'm going to call this actual change. And then I'm going to make a vector 3, which is going to be called the new position, which is going to be the current position plus the actual change. Then I'm going to say the new position, we can set the magnitude. Feels a little bit weird. You can't set the magnitude. Can you not? Really? I still have to do it myself. All right, that's fine. We want to make sure that we're always, say, between, I don't know, 2 and 20 units away. We'll pick some number. Minimum distance, maximum distance. I guess we'll do that as a variable. Float min distance So we can never get closer than 2 units. Max distance, I don't know, we'll set 25. Okay? So we want to make sure that the magnitude of this vector is always between those two numbers over there. So we're going to take this. We're going to take the normalized version, which means a single unit vector, and we're going to multiply it by its new magnitude, which we are going to clamp. Mathf.clamp lets us clamp a value between two numbers. We're going to start with the current magnitude, but we're going to say the smallest number is the min distance, and the biggest is the max distance, like that. And then we'll just set the camera to be equal to this. So let's see what that looks like. Shouldn't min and max vary different spaceship design? Possibly. But we have something that's tunable. So there you go. Now I can't get further than 25 units away, which is really clear here because I'm in a straight line. And if I zoom in, -2. And then if I orbit around, the logic still works. Now, to me, I think I want to invert the mouse axes here because right now, scrolling up puts us further away, and scrolling down puts us closer in. And to me, I kind of feel like it should be the opposite. But again, this is another one of those cases where people are like religiously opposed to some other variant. So if I do this, to me, and especially when I think about it, it feels like scrolling up should be moving the camera forward. So now I'm scrolling up, and now I'm scrolling down. To me, that feels more natural. But your mileage may vary. The hell am I? Your mother? No. Do what the hell you want. And set up options, right? Again, you could have a Boolean here. So these should all be publics now. The reason I don't do them public at first is because if you make them a public, changing the values in the code here will not actually affect your in-game unit. So you'd have to go and change it in the inspector. So invert zoom direction, which is obviously going to be set to false, and we'll do something. So I'm going to keep the negative in here first because I think this is the more sensible default, and we'll say if invert zoom direction, then delta equals negative delta. Boom, done. Customizable. Hooray! All right, I think left mouse to zoom in, right mouse to zoom out. What? You're crazy! I do want to check to see, so page up and page down should also work here. Page up, page down. Really? Did I not set it in the input? I recall we did. I'm not going to stress about it if it doesn't work. Negative button, positive button. Page up, page down. Right, I have to set it up as a different type of key thing. I have to like add a new axis like this, give it the same name as that. But instead of mouse movement, it's key or mouse button. Absolutely. So cut out this, paste it here, cut out that, paste it there, no alternate positive button. So now if we hit this, page up, page down, whoa. The numbers go a bit cray-cray. I wonder why that is. You can tune it when you're doing a thingy like that, though. I can tune some of the behavior here. Just lower the gravity so it's like a lot more gentle. It's not absolute. There we go. That feels pretty good. Actually, it's the sensitivity number that matters. Gravity we actually probably would want to be 1,000, so it's instant. Gravity is what made it like, as soon as I let go, it still sort of kept going a little bit. It takes a while to rev up and to rev down. Here it's more instantaneous. Although there is actually something quite sexy about this. It was feeling pretty good where you like, you hold it, vroom, vroom, vroom. Like, I don't know if you can tell because you may not know exactly what I'm letting go, but like when I hit the button, it takes a second to ramp up to full speed, and when I let go, it takes a second to slow down again. That's what the gravity one is. Very cool. And sensitivity is the absolute amount. Like if I drop the sensitivity a whole bunch, like to this, oops, I guess I can do it live, that's fine. But if I do drop the sensitivity now, page up and page down will do very little. Very little, and then too slow for me. So you get to tune those numbers. That's very fun. All right. I like it. Boom. With this game going to be best controlled for analog rotations? Well, actually, that would be quite nice. I think that the actual building part of it, you probably works better with a mouse, although you could probably figure something out if you really wanted to bring this to console. But could you imagine something like Kerbal Space Program can come to a console? That's crazy! KSP would never work on a console, right? I don't know, apparently it does. They did bring it to... Did they bring it both to Xbox and PlayStation, or just PlayStation? I don't even remember. Hey, we could write things. This is like an Etch-a-Sketch all of a sudden. Whee! Alright, there's our spaceship. Alright, so I think we're good on the camera motions. I'm very happy about that. I suppose I can't pan the camera around or do anything, but that would be pretty easy to implement, right? So we've got the dolly. So let's also put in a pan camera version. Yeah, what the hell? It's going to take 2 seconds. So with this, void pan camera, all we're doing is we're going to... It's going to be very similar to the dolly. Let me actually copy this. It's going to be fine. Except we're going to do vector 3, which is going to be a new vector 3, where the x component is from input.getAxis horizontal, and the y is from input.getAxis vertical. And we're not going to do anything on the Z, although it's worth noting you could maybe do something with the mouse wheel in there, but then, I don't know, I think it's still kind of awkward. So we're going to grab that in there. And we are... input. I think we're just going to do something like this times something like pan speed. Again, I won't make it a public to start off with. Pan speed. Right. Set it to 1. We'll see what happens. I set it to this. So actual change is this. New position is going to be the... In this case, I actually am moving the rig. World position. We don't need to clamp or anything like that. That's fine. But if I did this right now and I hit the right arrow key, we're always going to move in positive X, irrespective of our actual true rotation, which isn't right. I don't think I want to use the whole of the rig's rotation. I think WASD, which is basically what we're doing right now, I think should always move sort of in a flat plane. So even if the camera's looking like this and like this, it should always, like X, or left and right should move this way. But more importantly is that forward and back should move like this, right? As opposed to like this, which is sort of what the zoom is doing. We want to move this way. So really all we care about is the rotation around the y-axis. And then we're going to use that to affect our position. That's very common. This is actually what you'll see in like all first-person shooters, basically, right? It doesn't matter if someone's looking at their feet. If you're pushing forward, then you're going that way. So even if you're looking down, you go forward, you go this way. Left and right is affected, however, by this, which is just the rotation around the y-axis. So what we want to do is the actual change. We want to do something like, okay, so again, this is just regular position, that's fine. The actual change, we want to rotate it. We want to rotate it around something. We'll use some Euler angles. So we're going to do this and that. You always have to put the quaternion bit first. So the x is 0, and the z is 0, and the y is going to be based on the camera rig's current rotation, Euler angles, y. That's the only one we're going to care about, and I think I'm doing this right. Let's find out. Play. Left, right. Whoa, that's really fast. Really fast. 0.1. Oh, 0.1 F, because it's a float, not a double. So, left, right. Okay, maybe too slow, but that's okay. Right. Vertical is not going to affect the Y. 0. Vertical is going to affect the Z. Because right now my W and S key were going up and down. So now we go forward, backwards. And it's worth noting that at this point, I'm moving the entirety of the rig. I'm not moving the camera, I'm moving the rig, which is different from the zoom, which might come up later. Okay, so that's fine that way. Now, I'm going to recenter the rig, more or less. I'm going to rotate around to the right. So now I'm going to go forward, back. Oh, I'm not doing it right. Really? Oh, wait. Right. Derp derp. Because I am back at the thing where I'm not actually rotating the camera rig. The camera rig has no rotation. Therefore, its Euler angle.y makes no sense whatsoever. So instead, I should actually be using the camera itself. What is it? Oh, the camera. Should be using the camera's rotation, y angle. So again, forward, back, right, left. Move to the side here. Now I'm going to go right, left, forward, back. Excellent. And yeah, I think we'll boost the sensitivity a bit. I think I'll just bring it up to like this, save it, make this public, and that'll be okay. And most importantly here, there we go, is if I pan this way and I move forward and back, and again, I'm moving the rig, I think that's good, right? So if I'm looking straight down and I move forward, I'm not moving the camera close. I'm only moving on the world z-axis here, or, you know, or x-axis. There. I think that's pretty happy making. So now we can look around our object. We do have the fast zoom this way, which always gets us closer to whatever our focal point was. And we can move the focal point is basically what's going on here. All right. This feels okay. All right. Good. Fine. You might want to change the WASD. You might want to change it so that the forward and back actually moves you on the angle. It's up to you. All right. All that. Now, what I want to do is... Oh, man. We're a little over our time budget already. I want to work on a little simple user interface right now, because right now, the only way I can change what blocks we're plopping down is for me to go into the inspector over here and drag a different prefab into that. So if I want to be using triangle bits, there, now I can use a triangle bit over here and do, oh yeah, that I guess is fine. And then let's say I want to do thruster now, I got to drag that in there and put thrusters here, here, and here. So that's obviously super duper awkward. So let's work on a bit of a user interface for that. We could hard code in the buttons, which might be fine. Or we could get a little helper for us. Basically, all right, let's just get started real quick. What we're going to do is we'll make a new UI. Tell you what, I'm going to put the whole bottom, I'm going to have like a little toolbar down there. So I'm going to go with my UI, add an image. So by default, when you add your first UI component, it adds a canvas and an event system. And we got an image in here. Whether you use image or panel or whatever. What this is just a UI element that happens to have an image on it, which we're going to use sort of as a background of maybe a little toolbar at the bottom. We don't need it, but whatever. I'm going to go ahead and I'm holding Alt and Shift to set all the pivots. I'm going to have it stretch along the bottom, and I'm going to change the height to like 30. There we go. So we got a little toolbar area. It looks awesome. Shut up. It's cool. And in there, the idea will be that we're going to have some buttons in there, right? A button like this one, which by default we would like to have it, you know, maybe set over there. So this is the button to set a particular type of thing. So this is to switch to like cube, right? The cube button. And obviously that's a little wide. So maybe cut it in half, make it, I don't know, 90, something around there. Make another one. Let's actually make one for rectangle because it will be quite big. Okay, and then obviously this would have to be set off to the side, which is kind of a pain to manage. So is there a better way to do that? Well, yeah. Let's go and create an empty inside of the image. So this is our bottom toolbar, right? This is just the background for it. And then this empty is going to be something like our button group, something like that. And then I'm going to put these buttons in there. So what we could do is we could use a horizontal layout group over here. And say you want to be middle left oriented. Oh, right, I guess you want to be anchored to the left. And then what we can do is we can change the width like this. That works out pretty good. So then what you can do is you can set the width of this to be some multiple of how many things you have in here. That's a pretty easy way to do it. What if we also don't expand the width and tell these guys to have a layout element and say that I would like a width of 90. There we go. That works out much better. And then I think I could set this back to be full this way. There we go. Excellent. So then the alignment makes the difference now. So we could have it be middle centered, or we could say, go ahead and be on the middle left, which I think is good. So we just say we are not going to expand the children's width, and our children are going to have a preferred width, which means assuming it's possible, it will go and maintain that. So we can add in as many buttons in here as we want, and they'll keep being left aligned, which is great. Eventually, if we fill it up too much, things will start getting squooshed, which is obviously ugly, but you know what? That's okay. We'll figure something out at that point. Thank you to all our September patrons, i.e. people who've pledged in September and are supporting the videos from October to early November, and especially these Mike Check supporters. We've got Yuko Finn, Ole Peter Talgo, Adam Conway, Drazian, Jan Torrevel, Adjective, Michael McClintock, Aaron Doibson, Craig Mortel, Stephen Wendell, Julien Auger Lafont, Marius Fieldvold, Speedy Savant, Stephen Stager, Valiant Cake Fiend, Wes Olenboving, Jason Yanity, Kale the Quick, Neil, Blakey, Milner, and everyone who's watched, shared, favored, and subscribed to the series. Thank you very, very much.